Good morning to everyone. I'm Stefania Fabozzi from University of Naples Federico II in Italy. I've been hosted at the Tongji University of Shanghai in China for 3 months from October to December 2016 thanks to the GREAT project. During this period, I had the opportunity to work with the research group of Professor Yuan, together with Professor Yu and Professor Liu, to share and investigate some aspects of my research topic related to technologies for tunnel excavation in sustainable urban environment and the protection against natural hazard. Professor Yuan research group belongs to the tunnel and underground engineering where I spent my secondment. The department is equipped with a very advanced experimental center for geotechnical engineering. And in particular, the experimental tunneling laboratory is interested in rock tunnel. We can see the picture on the left and shield tunnel model testing system. On the right, the bending tests on the segmental lining of a shielded tunnel to define the bearing capacity of the lining and the rotational capability of the joints in both directions. The dynamic behavior of the tunnel is studied both in transversal and longitudinal direction with the centrifuge testing system, as we can see in the picture on the left, and a very advanced multi-point shaking table with the possibility of different configurations. The configuration A, in particular with the linear array, allows to simulate the earthquake propagation along the tunnel axis, as well as participate to the experimental activities in progress in the tunneling laboratories. I have developed a three-dimensional numerical model implemented in Plaxis 3D to simulate the effect of earthquake passage along the tunnel axis. In order to validate my numerical model, the obtained results have been compared with the same obtained in a three-dimensional numerical model in Abacus 3D. This slide shows the numerical model implemented in Plaxis. The domain had a length of 400 meters, a width of 200 meters, and a depth of 60 meters, with the tunnel in the middle of the domain at 30 meters of depth, with a 6 meters of diameter. The analysis has been performed under the hypothesis of an ideal soft soil with a linear elastic behavior, an ideal continuous lining with the linear elastic behavior of the structure model as a plate 2D element, with a no-slip condition between the soil and the structure, considering free field boundaries both along y and x direction, and the mesh dimension of the model has been set in function of the maximum frequency of vibration of the input signal. The input signal is an harmonic wave with an amplitude of 0.1 G, a frequency of 4 Hz, a dynamic time interval of 0.005 seconds. Input is applied at the base of the model with a number of surfaces, considering a time lag along the axis calculated in function of the bedrock velocity. A number of velocity values has been considered for different analyses. This is the longitudinal vertical section of the model. The analysis has been performed in a free field condition and in the soil structure interaction condition. The response of the points in the middle of the model on the top, in correspondence of the tunnel axis, has been compared with and without the structure to evaluate the filtering effect of the tunnel. In addition, the internal forces in the reference section has been evaluated. The effect of a wave passage along the tunnel axis is that to increase the transversal component of the forces and induce the longitudinal component also. A simplified beam spring multi-masses model for soil structure interaction developed by a PhD student of Tongji University has been adopted and implemented in Abacus 2D to compare the dynamic increment of longitudinal component of internal forces in the lining, which is a beam, in a 2D model. This model derived from the Japanese mass print model that is 1D system with 1 degree of freedom. Multimasses model considers a number of degrees of freedom until 10. My model has been described by one-dimensional system with 5 degrees of freedom, and in one-dimensional space, the upper figure shows the 2D equivalent Hammond system of the homogeneous soil layer. In longitudinal direction, the 1D system are connected with the springs element. The 3D model in Plaxis and 2D model in Abacus allow to compare the bending moment in the horizontal plane around the z-axis and the shear acting in the vertical plane in the transverse direction of the tunnel axis. This is the main topic developed during my secondment in Tonge University, and thanks to everyone for the attention, and if someone is interested you can contact me at my email address.